Hello, Assalamualaikum. Today, I would like to present our coursework that has been given by our lecturer, Dr. Muhammad Hatta bin Jufri. Dr. Hatta has given us this assignment to find the information about the electrical power system in Malaysia. Before we start our presentation, I would like to introduce myself and I would like to introduce our group members. My name is Amir bin Kasni. My matric number is B0822105550. My group members we have Nur Muhammad Alif bin Rosli. The last one is Muhammad Afiq Muhammad Kamidun. Okay, here I would like to introduce what is electrical power system. Generally, as we know, the power system is a network which consists generation, distribution, and transmission system. It uses the form of energy like coal and diesel, uh, and it's convert into electrical energy. The power system includes the device connected to the system like the synchronized generator, motor, transformer, circuit breaker, and conductor and protection. The function of power system is to convert energy from other form to the electricity and distribute it to the consumer. As we know, the authorities that operate this electrical power system in Malaysia, we have the authorities. The first one is Tenaga Nasional Berhad. The second one is Suruhanjaya Tenaga. For the Tenaga Nasional Berhad, the operation is to the main utility company responsible for electricity, for generation, for transmission, for distribution, and sell the electricity throughout in Peninsula Malaysia. For Suruhanjaya, we know as the Energy Commission that was established in 2001 under the Energy Commission Act 2001. The role that the authorities are responsible for in the electrical power system in Malaysia. For Suruhanjaya Tenaga Malaysia, they're regulating electricity and pipe gas supply in Peninsula Malaysia and Sabah. Next, their role is to balancing the priorities of energy provider and consumer to ensure reliable, safe and cost-effective supply for electricity and pipe gas. The last one to serving as the hub for energy data and matter related to energy data in Malaysia. For Tenaga Nasional Berhad, their role is to generating, transmitting, distributing and selling the energy to the consumer. And the last one is to ensuring reliable electricity supply in Peninsula. This is the flow of the electrical power system generation. What is generation in electrical power system? As we know, generation in power system is the process that converting some form of energy into electrical energy. It serves as the primary source of energy within the power system and operate continuously. The process of producing electrical energy from various sources such as coal, natural gas, nuclear, hydroelectricity, wind, solar, and others. In generating station, these are where electrical energy is produced. They can be thermal power station, hydroelectric power station, and nuclear power station. How different generation power system method works. The different type of power plant utilize different mechanism to generate electricity. For instance, fossil fuel power plant, they burn coal, oil, and natural gas to produce the steam, which drive turbine connected to generator to produce electricity. Nuclear power plant use nuclear reaction to generate heat, which also produce steam to drive the turbine. For renewable energy source like hydroelectricity, wind, and solar power, harness natural forces directly to generate electricity. Transmission. What is transmission in electrical power system? The transmission in electrical power system is the process of delivering generated electricity from power plant. It's usually over long distance and transmitted to the distribution grid located in populated areas. An important part of this process includes transformers, which are used to increase voltage level to make long distance transmission feasible. Here we have the process of electrical transmission through transmission line. The process is the power plant produce, as we know, the power plant produce AC electricity at the high voltage. The electricity is sent to substation. The voltage is transformed into a lower voltage to travel long distance for more efficiently. The voltage is stepped up for transmission. And the last one is the voltage is reduced, is stepped down for local distribution. Transformer. What is transformer? In electrical device, transformer is that uses electromagnetic induction to pass. In the electrical grid transformer are the key to changing the voltage to reduce how much energy is lost in electrical transmission. Transformer can change the voltage of the electrical signal coming out of the power plant. Transformer also reduce step down the voltage in substation and as distribution transformer. In conclusion, transformer are also used as a part of device like current transformer. How transformer works? Transformer work uses electromagnetic induction to change the voltage current. When a AC signal is applied to primary coil, the changing current can causes a magnetic field to change the to get the bigger or small result. This changing magnetic field and associated magnetic flux will pass through the secondary coil, inducing a voltage across a secondary coil. Transformer do not allow DC input to flow through. This is because a change in current cannot be generated by DC, meaning that there is no changing magnetic field to induce a voltage across the secondary component. The fundamental principle that allow transformer to change the voltage of alternating current is direct relationship between the ratio of loop or wire in the primary winding to the secondary winding and the ratio of the primary voltage to the output voltage. This is a simple operating transformer. The process of operating this transformer is primary current come in with a voltage primary voltage. The current passes through the primary windings creating a magnetic flux in the iron core. This flux is traveling through a secondary winding loops of wire on the other circuit. This creates a current, secondary current, and a voltage different in the second circuit of secondary voltage. The last one is the electric power V times I still stay the same.
Alright, so for the next system in power system is distribution. So a distribution power system is a network that delivers electricity from transmission line to consumers, whether they are residential, commercial, or industrial users. So the system is the final stage in the delivery of electricity to end users, where the voltage is reduced from the high levels used for transmission to the lower levels suitable for common use. So there are seven stage or seven equipment in distributions. So the first is substation, where these facilities transform high voltage electricity from transmission lines into lower voltage suitable for distribution. They also provide switching capabilities to control the flow of electricity. Next, the distribution lines. So these are the cables or wire electricity from substation to home, business, and other end users. Distribution lines typically operate at voltage ranging from a few thousand volts to a few hundred volts. Next is transformers. So transformers are used to step down voltage levels from the distribution lines to levels appropriate for household or commercial use. They can be pole mounted or peg mounted depending on the application. So next is switchgear and protection device. So the switchgear is used to control the flow of electricity and to protect the distribution system from faults such as short circuits or overloads. Protection device include fuse, circuit breakers, and relays. Next is meter. Meter are installed at consumer premises to measure the amount of electricity consumed. This information is used for billing purpose. Next is distributed energy resources, DERS. They are small scale power generation units or energy storage system connected to the distribution system. Example include rooftop solar panels, small wind turbines, and battery storage system. Lastly is control and monitoring systems. This system allow utilities to monitor and control the distribution network in real time, optimizing operation and responding to events such as outage or change in demand. Alright, next we go to loads in electrical. There is several types of load in electrical, whereas domestic, commercial, industrial, municipal, irrigation, and traction. So the first one is domestic. The domestic load consists of lights, fans, refrigerators, heaters, television, small motor for pumping water, etc. Next is commercial. The commercial load consists of lighting for shops, fans, and electrical appliances used in restaurants, etc. Has seasonal variations due to the extensive use of air conditioner and space heaters. Next is industrial load. The industrial has a small scale industry requires up to 25 kilowatt, medium scale industry between 25 kilowatt and 100 kilowatt, and the large scale industry requires load above 500 kilowatt. Next, we go to municipal load. Municipal load consists of street lighting, power required for water supply and drainage purpose. Next is irrigation load. The irrigation load, the electrical power need for pumps driven by motors to supply water to fields. Generally, this type of load is supplied for 12 hours during night. Lastly is the traction load. So the traction load includes train, cars, trolley, buses, railways, etc. So these systems utilize electric power to drive motors that propel the vehicles.
Assalamualaikum and good morning. So I want to present about protection in the electrical system. So we have a 3 point of content. So the first one is the importance of protection device in the electrical power system. Common protection device and their main component used in Malaysia. Number three is TMB ensure adequate protection measure for the power system. So the content number one is we have a 6 1. For example, the first one is a personal safety. The next one is equipment protection, system ability, grid stability, power quality, and regulation completion. So we go move to content number two. So we use a three device. Three device, for example, we use a relay, switch breaker, and battery. So for the relay, we have a sensing element, contact, electromagnetic, coil, trip, and application. The next one is a circuit breaker. The point is operating mechanism, contact, tripping unit, actuation system, and application. For the last part is battery. So for the battery, we have electrode, electricity, separator, and casing, and application. We move to content number three. Content number three is TMB ensure equipment protection measure for the power system. So for the relay, we have four point. So the number one is selection and configuration, regular maintenance, testing and commissioning, remote monitoring. For the circuit breaker, we have a 3 point. For example, number one is routine inspection and testing, selective coordination, remote operation. For the battery, we have a 3 point. Number one is regular maintenance and testing, environmental control, backup power system. So this generation in Malaysia, we have 12 place. Number one is Sultan Salahuddin Abdul Aziz Station, Manjung Power Plant, Pakundam, Jimah Power Station, Tanjung Bin Power Station, Kapar Power Station, Sultan Mahmud Power Station, Murandam Solar Power Plant, Tanjung Gelawing Farm in Sarawak, Sultan Iskandar Power Station, Bombay Cycle Power Plants. So for the hydro in Malaysia, we have a six place is Bakudam, Batu Dam, Kenyir Dam, Sultan Mahmud Dam, Tek Brown Dam, Pedu Dam. So for the last part is a transmission in Malaysia. Is a transmission in Malaysia. So thank you. That's all my present, and have a nice day.